So we're going to look at the two different typical prisms for a total station instrument. Here's a standard target, and it can be used two different directions. There's no right or wrong for which one you choose, but you just need to make sure that you're aware of what offset you're using so that you can enter that properly into your total station. So at a negative 30 millimeter offset, notice this prism is kind of set back into the target. So here's the back of the prism assembly. It's actually measuring just slightly behind the center of the target. So the rod would be connected at this point. The center of the rod would be here. So these can unscrew, and this is where then the prism would be measuring to. So slightly offset to the back. That's a negative 30. The other option is a 0 millimeter offset. So notice this one protrudes a little bit more than the other one. Again, the center of the rod would be measured to this point, but this one is on the 0 side, so it does not do any adjustments as far as where the measurements are being taken to. Just remember, these need to be set in your total station, and you can see which one you're working with on the face of the target. On this particular instrument, if we were going to set the prism constant, we would use these measure buttons. So this instrument actually gives you two different options to set settings in for your measurements. For this one, we would just hold in the button until we get this menu. Notice we have options for a target. So we can sight a target, or we have in prism for non-prism, which means we wouldn't need a prism. This one has the capability to take readings without a prism. The conditions have to be right for that to happen though, and the distance is limited to how far away it can go. So the constant, this is from our prism target, is here. So even though we have negative 30 on our prism target, this particular instrument has to have the setting entered as a positive value. That has to do with Nikon optics. So make sure that with the total station that you're using, you're aware of how the prism constants need to be entered in there. The mode is how precisely it will measure the distances. So we have it set to precise, and it's going to try to measure them down to 4 decimal places. It's going to average the distances one time, but you can set these things to different. The more you up these numbers or increase the average or reduce the precision, the more precise and accurate your measurements are going to be. So that is prism constant. Once we have our temperature and our pressure and our prism constants set, the next thing we'll be ready to do is start measuring. So if you remember from lectures where we talked about how to determine directions of lines, before you can do that, you have to have a starting reference line. And so with a total station, we have two different options of how we can set that. But you have to set it before you start measuring, or your measurements won't be related to anything. A common simple thing to do is to aim towards your back sight and set the instrument to a 0 degree horizontal angle. That way, your measurements, the angles are what they are. You don't have to calculate them after the fact if you need to see specifically what the angle is. So first you want to sight at your back sight, lock down the instrument and get it precisely in position. Once it is precisely sighted onto your sight, your back sight, we'll need to set 0 for the horizontal angle. Notice right now it's just some random number, 171 degrees. So for this instrument, we hit the angle button and we have options. So 0 set is option number 1, but we can also type in a specific angle if we wanted to. Right now we'll go with 0 set, so I hit enter. And notice now that the horizontal angle is set to 0 degrees. So if I unlock the instrument and turn, the angle starts to change. That is giving me angle to the right. So in surveying, we always want to measure in angles to the right, or that's the standard typical value given. You don't actually have to turn the total station to the right. Notice I've gone past 0 and it's now measuring in the 340 range for the angle. The angles always read out as if you turn them to the right, but you can turn the instrument any direction that you want to. As far as the vertical scope and the vertical angle, that's listed here as a VA, and you can't necessarily set this angle because a vertical angle is based off of the position of the scope, not necessarily where your sights are. So for example, notice as I move the scope upward, the angle gets smaller. You can set the setting in your total station to read either a zenith angle or a vertical angle. So zenith angles measure straight up. 0 degrees is their point of reference, and so 0 starts at the top. Notice my eyepiece is all the way down here at the bottom. If I lock this down, you can see I can get it right on 0. As the telescope is turned downwards, the angle climbs. So when we have the telescope pointed straight down, we're going to see it close to 180 degrees. If it's completely level and aimed in a level direction, you'll see it at 90 degrees. And if we turn the scope all the way over into what we would consider reverse or indirect mode, notice it is close to 270 degrees. So the vertical reads all the way around, but it is what it is. It's not something that you set. The horizontal distance is listed down here. To get a distance, we would, for this instrument, hit a measure button and it would give us a distance. You can change these displays on a lot of instruments to show different kinds of measurements. So on this one, if we hit the display key, we now see horizontal angle, vertical distance, and horizontal distance. And there's just several different options. You can see those change here. Pretty standard is to see this setup, a horizontal angle, vertical angle, and a horizontal distance, or a horizontal angle, vertical distance, and a horizontal distance.